So today we're going to talk about some important test circuits, going through what seems to really be important when dealing with integrators, which is the heart, besides the multiplier of the quadratic integrate and fire, are the open loop gain and the offset voltage. Now, gain bandwidth would also be important, but with a time constant of 1 for our integrators that I've been using, um, we can get away with smaller gain bandwidths, and so we've been trying to maximize the open loop gain at DC. So let's talk about the offset voltage first. All right, here are two circuits. All right, um, this one will measure the offset voltage, and probably what you wonder where the input is. Well, the input would be an offset voltage right here, and so you'd have a non-inverting gain stage. So it'd be 1 plus 51k divided by 51, so 1001. In data sheets, they'll say the gain is 1000, but it's really 1001. Now we have an improved circuit, but make sure to realize that the op amp has been flipped, all right, because we're actually putting another op amp inside the feedback loop, right? So that's kind of a 110 type thing. And what this does is multiply the open loop gain by these two, by each other. But it's inside the feedback loop, and so what tends to happen is that it just kind of becomes like a super op amp. And interestingly enough, this can have an offset voltage different from this, and it still will measure the output voltage here. The gain is still going to be 1001 times the offset voltage, which is inside here, but it's a voltage source. I mean, we could just easily put a voltage source right in there if you're really trying to see what's going on, right? Right. Then you could see that it's a non-inverting amplifier. All right. Now, if you look inside, I've got the open loop gain as a parameter and the V offset as well. So you can see that here. So what this is, it just does a DC simulation. So in fact, this becomes an open circuit, and it'll sweep the open loop gain from 1 to 1 meg in steps of 1. So if we run the simulation and plot it, now because it was a decade type step, it's best to run this as a decade, and then you look at the output, you look at the offset voltage from here. Now, yeah, this circuit does invert the offset voltage. That's okay. So it's really a positive offset voltage. But notice V out in green, the simple circuit, versus V out in blue, which has this enhanced op amp technique in it. Notice as open loop gain of 1, 10. See, it's not really working. So remember, we put in a 1 millivolt offset voltage, so really 1,000 times that is 1 volt. But look, we need, before the first circuit becomes really accurate, we need an open loop gain of greater than 100k, which has been pretty hard for us to get. Um, I've been playing with it, I've been getting 50k, right? But notice in the enhanced circuit that even an open loop gain of 1,000 is giving us the proper gain. So given that we've been between 20 and 50k, this is going to be the circuit we need to use to verify our offset voltage. Now what I would do is that we need to start developing test boards and test circuits, you can just use any old op amp. I might even recommend using the 741 because it does have such a large offset voltage. And to make this circuit, and yeah, you're going to need to make a board and then a test protocol that then you could kind of take pins and plug it into that board so that you could test the op amps when they come back. Then the other thing is the open loop gain, and it has the same kind of circuit. Oh, just one thing. This is flipped, all right, but then it goes into the inverting input here, all right. So just make sure these are backwards. I messed it up myself, so anyway, here's a circuit that will measure the open loop gain very close to DC. Um, you can see we've got the same structure, right? And all we do is input a voltage here. And I'll have to show you the link where this circuit comes from, but basically you force this to be a certain output, then it becomes a voltage division on the input, and if you know this and you know this, you can actually calculate the gain, which is kind of interesting because you find the peak to peak voltage of this and then divide it by the peak to peak voltage of the output. Normally gain is the output divided by input, but in this time it's backwards, and then you multiply it by 1,000. Now what can happen is that if the open loop gain is small, this will change quite a bit, and sometimes you have to change the peak to peak. I've kind of got it set up in a, I'm hoping the best of all worlds. So, and it even works with an offset voltage because we're measuring peak to peak. The fact that there's an offset voltage is okay because we're still doing peak to peak. Then I have the measurement commands here, right? And so this is the open loop gain, right? And then this is the measured open loop gain. And at 10, we're getting 10, 100, 1K, 10K. And so we've been in the 50K range, and it's pretty accurate. 56 and change, 55.5, that's very close. But at 1 meg, right, it's starting to deviate. Even at 800, it's starting. The thing is it takes a little more circuit effort to get higher gains. But yeah, the LT101 has about an 800K gain, so that's pretty good. But for a two-stage op amp, we're in this range. We're down in this range, and even if we were able to get 100K, it's still a good measurement. All right. Now, just what's going on? So this is the input. It's the same peak to peak, and here's the output. All right, and that it starts off with a low gain, and the output is big. So the peak to peak of the input is always the same. So you just find the peak to peak of this, and yeah, notice it only goes up to a little over 0, goes lower here. You're just measuring peak to peak. That's due to the offset voltage, right? And then the sinusoid gets smaller and smaller, and so because this output, you're actually dividing by it as the peak to peak of this gets smaller and smaller, the gain goes up. And remembering that we're multiplying it by 1,000. So this is another classic test circuit that you should build now and start actually testing to make sure that all of this works. what I found is that 10 hertz would actually be a faster test, 10 times a second. But the parasitics, or I think something's going on here to where actually, as we increase the frequency of this, we're actually getting that gain bandwidth slope. So, but 5 was about as fast as I could go before it started affecting the measurement. Now, yeah, 1 is better, but if you've ever tested a 1 hertz signal, it is like a pain. So 5 is pretty good. I will save these and upload them. So what you should also do is replace these with that op amp that I've created and make sure that it's still working. I know I'm still working on the cadence, but the thing is we got to make sure that we build the right thing and we actually know how to test it. Otherwise, otherwise it's a mess. So to rush into drawing something that is the wrong thing to make isn't good. So I know it might seem that we're not making progress, but um, being able to test these two things is super important.